Assalamu alaikum warahmatullahi wabarakatuh. In this video class, I'm going to explain the chapter 11 of your physics portion, which is thermal energy transfers, right? So first, as we usually do, we have to first understand what the title is, right? So here we have three terms in the headline. So thermal energy transfers. So basically, thermal is connected to heat. And energy is the ability to work. And transfers mean moving from one place to another place, right? Okay, let me move to the first slide. Right. So here I have mentioned the definition of energy, right? So energy is simply the ability to work, right? So here the ability to work uh, is called uh, energy, right? So the energy means the ability of matter or radiation to work because of its mass, movement, electric charge, etc. Right? Then we have types of energy. We have several types of energy. I have listed out there, right? So we earlier studied about mechanical energy. Mechanical energy is the combination of potential energy and kinetic energy. And we have gravitational energy, right? So we are standing on the Earth because of this gravitational energy, right? And if you drop an object from an altitude, it will fall towards the Earth because of this gravitational energy. And we have light energy. Okay, I have replicated this gravitational energy. Okay, then we have thermal energy, right? I'm sorry. Right. So we have thermal energy. Thermal energy is equal to heat energy. Both are same, right? Thermal energy and heat energy. Then we have nuclear energy and chemical energy, and we have studied a lot of energies, right? Then we will see what transfer means, right? So in the title itself, we have thermal energy transfer. So we have studied what is thermal. Thermal is connected to heat. Thermal energy means heat energy. Then energy is the ability of matter or radiation to work. So if you want, you can just highlight these sentences. Okay. Oh, I'm sorry. The ability to work is called energy. Then we looked at the types of energy, and here out of this energy, we are going to study about this thermal energy, right? This thermal energy. Then we have transfer. Transfer means to move one place to another. For example, here you see the example sentences. How can I transfer my money from my bank account to his, right? So here you have your bank account here. From your bank, you have some money, right? So you have some money. So to another person's bank account, you have to transfer some amount of money. So moving one place to another place is called transfer. Here, the second example says the patient was transferred to another hospital, right? So from this hospital, if it is the hospital one, and the second hospital is this. Now if he is a patient, now he is going to be rushed to another hospital. So the patient was transferred to another hospital. So simply transfer means moving one place to another place, right? Okay, right. Now we will move to the second slide. Now here I have mentioned some points. We can read them. Thermal energy refers to energy contained within a system that is responsible for its temperature. So here we have some terminologies: thermal energy, temperature, heat, right? Okay. Now, if you look at what thermal energy is, it refers to the energy that a body or system contains, and this thermal energy is responsible for the temperature. So for example, let's say okay, now we will take our room, right? So let's say we have this room, and this room is at room temperature, let's say 25 degrees Celsius, right? Now here, this 25 degrees Celsius, this quantity is called temperature, right? Temperature. So this temperature is due to the thermal energy. Okay, so due to this so here we have some amount of energy. Within this system, we have energy, that is heat energy. And that heat energy is responsible for the temperature. Now, when the temperature increases, which means the energy that the body contains is increasing. For example, if it is 0 degrees Celsius, then the energy is less. Then when temperature increases from 1, 2, 3, likewise, the thermal energy that the body or system contains is also increasing, right? Okay. Now, if you look at the second one, temperature is a physical quantity that quantitatively expresses the attribute of hotness or coldness, right? So here we say if the temperature is less, we say coldness. If the temperature is high, we say hot, right? For example, if you take an ice cube, right, the temperature might be minus 4 degrees Celsius or minus 10 degrees Celsius. So if it is minus 4 degrees Celsius, we will say this is cold, right? Because the temperature is very less. Now, if we take a hot water glass, right? So this glass containing water, hot water, let's say this is 80 degrees Celsius, 80 degree Celsius. Okay. So here, if it is 80 degrees Celsius, we will say this water is hot because the temperature is high. Okay. The temperature is high. Now, okay, now the second point is temperature is measured with a thermometer. So normally this is a quantity. Quantity means it has value. So 25 minus 4, 80. These are quantities. Now to measure these quantities, we use thermometer. So temperature is measured with thermometer. That is the next point. Now, if you look at this point, thermal energy requires temperature difference if it is to be transferred, right? For example, let's say now for example, if you take an ice cube from an refrigerator and keep outside, what will happen? Okay, now if you take, let me erase all of this. Right. Now, if I take an ice cube, so let's say this is ice cube, minus 4 degrees Celsius, minus 4 degrees Celsius, minus 4 degrees Celsius. Now this is in the refrigerator. So this is refrigerator, right? This is refrigerator. Now, if I keep this ice cube outside to the environment, what will happen? Now the room temperature is 25 degrees Celsius. 25 degrees Celsius, the ambient temperature. And the temperature of this ice cube is minus 4 degrees Celsius. So there is a difference in the temperature, right? 25 minus 4. So, okay. So there is a huge difference in the temperature. So from the environment, this ice cube will acquire energy, right? Will acquire energy. And now, okay, the temperature of this ice cube will gradually increase. So minus 4, minus 3, minus 2, minus 1, 0, right? So now the ice cube will come to 0 degrees Celsius, right? So at 0 degrees Celsius, what will happen? Melting will occur. We have already studied about melting. So the constant temperature in which the conversion in phase occurs, right? Okay. Now, from 0 degrees Celsius to 0 degrees Celsius, this is called melting point. Then after reaching 0 degrees Celsius, all the ice cube will become liquid phase. Then it will again gradually increase, right? So 0, 1, 2, 3, likewise, it will increase. And since the environment has a lot of energy, it will happen until the ice cube acquires the temperature of 25 degrees Celsius, right? There might be a small decrease in the atmospheric temperature, but it will not be, big, right? Because the energy that the environment has is very big. Okay. So sometimes it might come to, this water might come to the ambient temperature 25 degrees Celsius. So here, if there is a temperature difference, the heat energy will transfer. So from the outside, from the environment, the ice cube is acquiring energy and becoming 25 degrees. So becoming water with room temperature, right? Okay. Right. Now the next point is heat is the flow of thermal energy. Now heat, right? For example, if I take a rod, if I take a metal rod, Now I am heating this metal rod with a Bunsen burner, right? With a Bunsen burner. Okay, right. Now this area will be hot. This area will be hot. And this area will be cold. Which area? This area. This area will be cold, which means the temperature of this area will be high than this area. Okay, so here from hotter place to colder place, the thermal energy will move, right? So this flow is called heat, right? So the heat is the flow of thermal energy, right? And if you look at this point, thermal energy requires a temperature difference if it is to be transferred. Thermal energy transfer from hotter place to colder place, that is from higher temperature to lower temperature. For hot means, as I explained, if the if the hot water is 80 degrees Celsius, the temperature of that water is high. From higher temperature to lower temperature, or from hotter place to colder place, the thermal energy will transfer. Now, there are three ways of transferring thermal energy. The first one is conduction, the second one is convection, and radiation. So we have to look at these three different methods of heat transfer in this session, right? Okay, now as you can see in this picture, now here you see conduction. So normally a person is holding this rod, and through conduction, thermal energy is transferring. Okay, so here they have set a fire, right? They have set a fire, and they are bringing the hand above this fire, and they might feel heat. So this is due to convection, because heat is transferring through fluid. Fluid means anything that can flow. Normally we say gases and liquids as fluid, right? And radiation, here you see radiation, right? So if you keep your hand right above the heat, you will feel heat because of convection. If you bring your hand near to the fire like this, right? So you will feel through radiation. And if you keep a rod, okay, if you keep a metal rod in the fire, so through that rod, okay, earlier before you keep this rod in the fire, you will not feel any heat. But when you keep this rod on the fire, after some time you might feel a heat in your hand. So because this is because of conduction. Okay. Okay. Now we will see what is conduction. Right. Now, if you look at this picture, here this person is holding a metal spoon. So he will feel coldness, because metals are good conductors of electricity and heat. Now, your body temperature is around 37 degrees Celsius. So what will happen is this metal spoon will conduct heat from your body. So some amount of heat energy is transferring to this spoon through this metal. So what will happen? Your temperature will reduce. So you will feel coldness. For example, if you spray some perfume on your hand, you will feel coldness, because to evaporate, the perfume is absorbing energy from your hand. So your body temperature reduce at your hand. So that's why you feel coldness, right? And when you, okay, for example, this is how energy transfers occur. So for example, let's say your mom is cooking rice. Okay, so you touch the rice cooker. So what will you feel? You will feel heat, because here the rice cooker is at the temperature than your body temperature. So your body is 37 degrees Celsius, right? 37 degree Celsius, let's say, and this is, let's say, around 80 degrees Celsius. Okay, so this gas cooker is uh, this gas cooker is I'm sorry. Okay. Now this is 80 degrees Celsius. So what will happen from higher temperature to lower temperature, the energy will transfer. Now, if you touch this gas cooker, from this, some amount of energy will go into your body. That's why your hand feel heat. Okay, right. Now, let me stop this presentation and go to your book. Right. Now, this is chapter 11, thermal energy transfers that you sent to me, right? So first we have to study about conduction, right? So they have given an interesting fact about this reindeer's nose. Okay, so you can just go through it. That is for your extra knowledge. They will not ask any questions from this, right? So here conduction. Okay, so they have mentioned some key terms, right? So if you look at these keywords, thermal conduction is the transfer of thermal energy by the vibration of molecules. So normally this conduction happens in solids, right? So both metals in non-metals, right? So okay, now you know how particles are arranged in solids, whereas for example we have three methods of energy transfer. What are they? Conduction, convection, and radiation. Now for convection we need fluids mean anything that can flow, both liquids and gases. So here, if you look at the arrangements of particles in solid, they are tightly arranged together. There is no space, right? So they cannot freely move as they wish. So when you heat, right, for example, here you see, right. Now, explaining conduction in metals and non-metals. Okay. Okay, so explaining conduction in metals and non-metals. Both metals and non-metals conduct thermal energy, right? So conduction happens in solids, both metals and non-metals. Metals are generally much better conductors than non-metals. So though both metals and non-metals conduct electricity, metals are the better conductors, right? We need different explanation of conduction for these two types of material. So what are the types of materials that we are going to look at? They are metals and non-metals. Right? Okay. Right. Now here you see, we will see how energy transfers occur in glass. So here we have used a Bunsen burner to heat this terminal of this glass. So this area is hot and this area is cold because it is in contact with the environment. So this will be at room temperature. Now we are heating this point. So what will happen? The particles at this point will get heated and they acquire energy from this source of energy, from this source of heat, right? So when they get heated, the molecules will vibrate. So when they vibrate, they will collide each other. So through collision, from this point to this point, energy flow occurs, right? Okay. Now here you see they have mentioned some other terminologies: thermal conductor and thermal insulator. So thermal conductor is a substance that conducts thermal energy. For example, metals are best thermal conductors. And thermal insulator means a substance that conducts little thermal energy. For example, wood, right? Wood is thermal insulator. For example, here you see touching a metal spoon, touching a wooden spoon, right? So metal spoon. So for example, if you are using a metal spoon to stir your tea, you might feel much heat, right, at the handle. But if you are using a wooden spoon, you will not feel heat, right? So that's why if you look at ladles to cook rice, we use ladle, right? So the handle of ladle is made up of wood, because the wood is thermal insulator. It conducts little thermal energy. We cannot say wood doesn't conduct thermal energy. It conducts, but a little amount, right? So here, now figure 11.4a shows touching metal spoons. Now this person is touching a metal spoon. Now if you want to, okay, now if you are drinking a tea, now you are stirring your tea. So if you are using a metal spoon, your spoon will be hot. And if you are using a spoon made up of wood, you will not feel much heat, because the wood is thermal insulator, right? Okay, now we will see this, and how we will see how energy transfers or thermal transfer occur in both metal and non-metal. Which non-metal and non-metal means wood and metal spoon. Okay, now when your finger touches a metal object, thermal energy is conducted out of your finger and into the metal, because metal is good thermal conductor. So you have to bear this point in your mind. Metals are good thermal conductors, but non-metals are also thermal conductor, but that might be thermal insulator. Insulator means they conduct electric, okay, they conduct heat, but little amount. Okay, so metal is a good thermal conductor. So if you want, you can highlight this sentence, right? Right. Thermal energy spreads rapidly through metal. So, okay, now if you are using, let's say, okay, this is your cup of tea. This is your cup of tea. Now you are using a metal spoon to stir this. Now what will happen? This tea is hot. Okay, this tea is hot. So this area will be hot, and this is you are keeping, right? You are holding this spoon with your hand. So this is at your body temperature. Let's say 37 degrees Celsius. And let's say this is 70 degrees Celsius. This tea is 70 degrees Celsius, very hot, right? So you are stirring, you are adding some sugar and stirring. So what will happen? From a higher temperature to lower temperature, the energy transfer will occur, right? So gradually, this you can feel, right? With time, the heat will increase. Okay. Right. Now, thermal energy spreads rapidly through the metal. Thermal energy continues to escape from your finger, leaving it colder than before. The temperature sensitiveness. So this is the scenario. Okay. Now, if you are barely touching a metal, right? Metal is a good conductor. Now, as I explained earlier, if you are just holding a metal spoon, what will happen? Okay, now this metal spoon is at room temperature, that is 25 degrees Celsius, but your body temperature is 37, higher than the room temperature. So what will happen? Some amount of energy, heat energy from your body will transfer to the metal. So that's why you feel you are touching something cold, right? For example, if you spray some amount of perfume in your hand, to evaporate, the perfume is absorbing some energy from your hand. That's why you feel some coldness in your hand. Okay, so leaving it colder than before. The temperature sensitive nerve, then it is biological related thing. The temperature sensitive nerves in your fingertip tell you brain that your finger is cold, so you think you are touching something cold. Okay. Now, in contrast, when you touch a wooden object, thermal energy conducts into area that your finger is in direct contact with. However, because wood is good thermal insulator, right? So wood is thermal insulator. Sometimes they might ask direct MCQ questions, right? So underline the thermal insulator. They might give 4 responses: metal, wood, and plastic, something like that. So you should underline the wood, right? The thermal energy travels no further. Your finger loses no more thermal energy and remains warm. So now when you touch a wooden spoon, it will, the spoon will not get energy, right? It will gain only a little amount of energy from your hand. So you will still feel like you are touching something warm, something warm. So warm and hot. So warm is convenient, but hot is we don't like hot. So both terms are different. Warm is okay. Now bearable temperature. Hot means unbearable temperature. Okay. Now note that the nerves in your finger tell you how hot your finger is, not how hot the object that you are touching is. Now this is also very important. Though this is 80 degrees Celsius, your hand will tell how, okay, what is the temperature that your finger is, right? Not the object, because there might be some energy loss to the environment also. So your nerves in your finger will tell how hot your finger is. It can read only your finger, because the nerves are directly connected to the finger only, not to the object. Okay? Right. Now, then what we here to discuss is, right. So they have given some experiments. When we look at the questions, we can do them, right? Now we will go to this part. Explaining conduction in metals and non-metals. We have already discussed this, right? Right. So you see here, if it is glass rod, right. Now look at the part. Okay. Now they are explaining about this figure 11.9 here. Right? Look at the particles inside the rod in figure 11.9. At the hot end of the rod, the atoms are vibrating much more than they are at the cold end, because they are getting energy. When they are getting energy, for example, you are eating, so you eat to get energy. If you are getting energy, you will not be sleeping, you will be working, you will be dancing, you will be walking, you will be running. So when something gets energy, it will tend to work. So when these molecules or these particles are getting energy from this Bunsen burner, they will vibrate. So when they vibrate, okay, vibrating much more than they are at the cold end. But here they will not vibrate, because they are not getting energy. Okay, so the molecules or the particles at the hot end will be vibrating. So when they vibrate, they are tightly arranged. The particles in solid are tightly arranged. So when they vibrate, they collide with their neighbors. This process results in each atom sharing its energy with its neighboring atoms, right? So when they vibrate, they collide each other, and this process leads to the conduction or the energy transfer. Okay, so these collisions gradually transfer energy from the atoms at the hot end to those at the cold end. Energy is steadily transferred down the road. So this process continuously occurs, and energy is steadily transferred down the or across the road. Okay, from the hot end to the cold end. So this is also very important. Energy transfers from the hot end to the cold road. Okay, now this is how poor conductors. So this process is for poor conductors such as glass, ice, and plastic. Conducts thermal energy. It is not a very efficient method of thermal energy transfer, because they are poor conductors. Okay, only the particles move. But if they are conductors, right, metals are good conductors for another reason. Many of the electrons, okay, now in metals we have free electrons. Free electrons are delocalized. Delocalized means they can move as they wish. They can move as they wish. These are the particles which carry electric current. So this is responsible for electric current, because energy is transferred through electrons with the movement of electrons. They also carry thermal energy as they get hot and move through the metal. Figure 11.10 shows a copper rod heated in the same way as the glass rod. Notice the free electrons which carry thermal energy through the metal. Right? So 11.10. So here you see, this is, it's supposed to be copper rod. Okay. So this is not glass rod. There should be a typing mistake, right? There should be a typing mistake. This is supposed to be copper rod, not glass rod, because we have already discussed how energy transfer occurs in glass rod in the previous figure. Now here this figure is copper rod, right? Copper rod. So copper is a metal. Copper. Copper. Okay. So here, if you look at copper rod, we have a lot of free electrons. So when they get heated, the free electrons will move. So the electric current, right? So the electric current will be formed. So from hot place to cold place, energy will flow. Okay. So here you can see conduction of thermal energy in metals. Metals have free electrons which carry thermal energy, making metals good conductors. So here in glass rods, particles get energy and vibrate. So when they vibrate, they collide each other, and through the collision, energy flow occurs. But here, the electrons are getting heated and they move, and due to the electric current, the energy flow occurs. So this is the effective way of thermal energy transfer. Okay? That's why we say metals are good conductors than non-metals. Okay, right. Okay. Now we can do some. Okay. Now we will go to the second method of energy transfer, which is convection. So here you can see, as we have seen, liquids and gases are not usually conductors of thermal energy. So liquids and gases doesn't conduct thermal energy. They only solids, metals and non-metals conduct heat. So if, okay, now we have three phases for, okay, so we have three states of matter: solid, liquid and gases. So we have already discussed solid conduct what is that? Heat energy. Now we are going to look at what about liquids and gases. They are basically fluids. Okay, right. Now they are not conductors. They are not usually, they don't conduct thermal energy. Thermal energy transfers in liquid and gases mainly by another method called convection. So convection. Okay, so I will tell an example, right? Convection. So they have given the keywords that you should know to study this the chapter convection. So convection is the transfer of thermal energy through a material by the movement of material itself. So here you see, when we heat metal, it doesn't move. It doesn't move. But if it is convection, the movement will be the material itself. Material means now the liquid is going to be moving and the gas is going to be moving. But when you heat metal, it will not move. Only the particles inside the metal or the solid vibrate. Okay, vibrate. Otherwise, if it is metal, the electrons will be moved. Okay. So the second one is fluid, a substance which can flow. Liquids and gases are fluids. Density, right? So you should know density. So I will just tell you an example. Right? Okay. Let me use okay. Right. Now we have a huge tree here. We have a huge tree. Now we set fire under the tree. Let's assume we set fire under this tree. Now we set fire under this tree. So what will happen? So if you kindle fire under a tree, the leaves of this tree will be moving. Okay, we will see why. Because okay. Now here, when we set fire, now we have a lot of gas molecules, air molecules in the atmosphere. These are gas molecules or air molecules, right? Okay. Now, when we set fire, the molecules near to this fire will get heated and they will expand. So when they expand, volume will increase. So when volume increases, density will reduce. So when density reduces, the molecules will tend to move upwards. Okay, so these molecules will move upwards, and hence here a vacant or vacuum will be formed. So to fill that gap, here these molecules will come. These molecules will come. So again, these molecules will be heated and they will go. So this process will continuously happening. So here you can see the molecules or the material itself is moving. So the air is literally moving. So when the air molecules move, wind will be formed. So when wind is formed, these leaves will be moving. Okay, so this is the reason why leaves move, or leaves move when the fire is set under a tree. So the second point you should know is convection current, the transfer of thermal energy by the motion of fluid. So convection current. So this motion or this movement or this flow is called convection current, the transfer of thermal energy by the motion of fluid. So if you look at this picture, right? So what they are telling is cold air sinks below any object which is colder than the surrounding. Now, if you look at this one, because water is clear and colorless, it can, okay. Now, if we are heating, uh, heating water in a beaker, right? So let's say we heat some amount of water in beaker, right? So we use Bunsen burner or whatever it is, right? Now, here we have water molecules, right? Here we have water molecules. Here we have water molecules. Now, when we heat this beaker, these molecules at the bottom of this flask will get heated and they expand. So when the temperature increases, they expand, the volume increases and density decreases. So when density decreases, they will move upwards to the surface area. So here a vacant or empty, this space is empty. So to fill this gap, these molecules will come, right? Then these molecules will be again heated and they will go. So this process will continuously occur here. But though this is happening, so here the water is moving, right? The water itself is moving, but we cannot see this movement unless we use any color, right? Because the water is colorless, we cannot observe this movement. So what we have to do is we have to use potassium manganate crystals. So now here you see, if you put potassium manganate crystals, now this area will be purple color, right? This area will be purple color. Now when we heat it, what will happen? These water molecules, so this area is purple color, means these molecules have become purple color. So what will happen when we heat it? These molecules will move this side, this direction. So this purple color along with the water molecule, this purple color also will move because due to the discontinuous nature of water molecules in between. So let's say this is water molecule, these are water molecules, and here we have purple color. The purple color, the potassium manganate is trapped between the water molecules. So along with the water molecules, the purple color also will move. So here you can see how convection current is occurring in when you heat water. So because water is clear and colorless, it can be difficult to see how the water moves to form convection current. So crystals of potassium manganate act as a purple dye to show the movement of water. So sometimes they might ask in your examination how you can observe the movement of water when it is heated. So you can see since water is clear and colorless, we can use some dye. In laboratory, we can use simply potassium manganate because that is a purple color dye. Okay, here you see method one, convection in a liquid, right? So in a liquid and in gases, we can study the convection current. So here we use potassium manganate. So this area will be purple color. And when we heat it, the purple color will spread in this direction, and ultimately it will go to the surface area. And after some times, the entire water will become purple. This is because of convection current. Right. And we have to study radiation. I think we have already studied this radiation in our previous class, but I didn't explain this convection and conduction. You just asked me to explain this radiation, right? So I have just explained the concepts that I didn't teach you, right? And we have completely studied this one. Okay. And we are doing the questions, I think, right? So we discussed the first and second question. Now we will study the fourth question. Okay. So we have already discussed these three questions, and we will focus on the fourth question. Okay. Now this diagram shows an electric water heater, right? So if okay. Now, if you are in the examination, this is how you have to think. Okay. Now, this diagram shows an electric water heater, right? So you have to just look at the apparatus. So here we have copper wall. Now, here we are cold water in. So this is inlet, this is outlet, and we are using electric immersion heater to heat the wall. Now, the copper wall is hot to touch. Name the process by which thermal energy from the water passes through the wall. So they are asking okay. Now, when we use electric immersion heater, when you touch this copper wall, definitely you will feel heat because of the conduction of thermal energy. So they are asking the copper wall is hot to touch. Name the process by which thermal energy from the water passes through the wall. So this answer is simply thermal conduction. Thermal conduction. Okay, right. Okay. Right. Now describe how heater at the bottom of the tank heats all the water in the tank. So this is very simple. As I explained you, here you see we are inserting water through this hole, and we are filling water. And what will happen? Okay. So here when we insert water here, these water molecules in this area will be heated. So when they get heated, what will happen? The density will reduce, and they will go to the upper part of this apparatus, which means here. So if you fill the water till this point, okay, let's assume we have filled this water. Okay, now in a steady rate, we are inserting water. Now this the water molecules in this area will be got heated. So these molecules will go to this area. Okay, now we have to fill till this point. Then only we can extract the hot water out. Otherwise, it will be difficult. Okay, so we have to. Okay, I'm sorry. Right now. Okay, we are filling to this point. So what will happen? These water molecules will go here, right? And here a vacuum will be formed. So these water molecule will come here. Then we can, okay, now now the heated water has come here. We can take it out, and we are continuously inserting water, right? So what will happen? Uh, this again the now these water molecules, the water molecules at this surface are still cold. Now they will come here. Now they will come here, and they will get heated. So this process will continuously happen, so we can get hot water out. Now, the hot walls transfer thermal energy to the surrounding, suggest a way this thermal. Okay, now to avoid the wastage of thermal energy, we can insulate it, right? So we can insulate it. So you can just tell, you just insulate the copper wall, so that, for example, as I explained, okay, during the winter day, Okay, you are heating the room, right? You are heating the room. So this is heat source. This is heat source. Now you are heating the room, right? Now okay, now when you heat the room, sometimes the energy might go to the surrounding or to the environment also. You are spending much money to heat this room. Now, if you have wastage, what will happen? You have to spend much money, and you will end up with a lot of inconveniences. So if you want to confine this energy into your room alone, you should insulate your room. And if you are using air conditioner to avoid wastage, you use you close all the doors and windows. Why? Because we have to confine the cooling inside the room alone. Okay. So insulate. So the hot wall transfer metal energy to the surrounding suggests a way this thermal energy loss could be reduced. Why? Just insulate the copper wall. Okay. So this, since this is one answer, you can just write insulate. So you can just write insulate the copper wall. So this is not even enough, because this carries only 1 mark, so that you can reduce loss of energy to the surrounding. This is more than enough. Okay. Right. Now we will try to do the fifth question. And we have two more questions. I think we will discuss these two questions in our next live session. Okay. So I have just, okay, in this video, I have explained, which I skipped in the last discussion. I just explained you radiation only. I didn't discuss the conduction and convection. Okay, so I have just explained those two ways of energy transfer in this section, in this video class. You can just watch this video, and if you have doubts, you can ask me in the next session. Okay, thank you.